In this video, I'll show you inefficiency of overcooling, cooling optimize, install, and reports. Most cooling units run at a fraction of their load, wasting energy. Can I turn some of them off? Temperature didn't change much. Can I save energy and turn off more cooling units? How many cooling units can be turned off before temperature changes are noticeable? Can I adjust cooling to match the heat produced by the equipment? Can I connect temperature sensors to the cooling units somehow? It's not that easy. Let's look at this simulation. Re-enabling this cooling unit has increased the temperature. This is because the increased air pressure pushes hot air back through the racks. Each cooling unit influences the airflow of the entire room. Mapping the influence of each cooling unit is humanly impossible, which is why we use a computer. Data center cooling optimization achieved with StruxureWare Data Center Cooling Optimize. Cooling Optimize combines software, hardware, and service products. Each cooling unit needs a control block. At least every third rack should have temperature sensors. There are 2 sensors per rack, top and bottom. There is also Cooling Optimize server, which could be placed in any rack. In DC operation, Cooling Optimize requires a specific license, and it's connected as an external system. Setup isn't different from any other external system, except the API token, which you get from Cooling Optimize server. After connecting to the Cooling Optimize server, you need to associate devices. These are monitored racks and controlled cooling units. Here, you see monitored racks highlighted. Let's have a closer look at Cooling Optimize overlay. For each cooling unit, we can see if it's on or off. We can also see its influence on the temperatures in the room. This unit is effectively cooling the right top corner. For monitored racks, we can see which units influence them. Red cooling units can increase rack temperature. This map is individual for every rack. Cooling Optimize server allows us to set temperature limits for racks and control the state of the cooling units. Overrides allow us to manually control cooling units. Temperature set points define rack temperatures. These are desired temperature limits for equipment. These are the actual temperatures of top and bottom sensors. Set points could be defined individually for each sensor pair, typically rack. The same data is available in Cooling Optimize Overlay and in Rack View. Based on temperature differences and influence maps, control signals are sent to cooling units. We configured Cooling Optimize. Cooling Optimize activity could be tracked using reports. Benchmark report is always comparing two time intervals. I'm selecting the period when sensors were installed, but no control enabled as a baseline period. Verification period is when Cooling Optimize had taken control of the cooling units. Between these two is a learning period. Cooling Optimize starts controlling cooling units and learns their influence on each sensor. We can see each cooling unit's power consumption for each of the time periods. Deploying Cooling Optimize saved 34% on our energy bill.